So, good day, grade 8 Makati Science High School students. For this lesson, we're going to be discussing about geometry, and of course, that's going to be on the topic of area and perimeter for Module 6 for the first quarter. So, let's start with our first problem. Okay, for this one, Eva wanted to create her personalized solar panel for her mobile devices. She constructed it in the shape of an equilateral triangle given here. Given the triangle LUV with an apothem of WA in which each side measures 4 meters, okay, let's say for example, according to this problem, all of the sides of the triangle is equal to 4 meters and it's an equilateral triangle, so it makes sense. So therefore, we need to find the area of the solar panel. So what's the area of this given figure? Okay, so we have two solutions for this one. We're going to find the area of the solar panel of the triangular solar panel using first this formula. Okay, so this is the special formula used for finding the area of an equilateral triangle. This is the special formula for that one. So that's s squared all over 4 multiplied by the square root of 3. And we know that the side measurement of the equilateral triangle solar panel is equal to 4. We can substitute that here. So that's going to give us 4 squared is equal, it's gonna give us 4 squared all over 4 times square root of 3. And that should give us 16 all over 4 times square root of 3, which is equal to 4 square root of 3 squared meters. Okay, so therefore, this is the area. Okay, this is the area of our solar panel. It's 4 square root of 3 squared meters. So let's try another formula. We're going to use simply the formula of the base formula, or the formula that we know for finding the area of triangles. So the area of a triangle is equal to 1/2. This is for equilateral triangle. 1/2 base times height. So how do we solve the height for this one? Grade 8. How can we find the height of this figure? So if the side measurement here is 4, we can uh, draw a bisector here. Okay, and this perpendicular bisector that we have drawn is going to create a right angle. And if it's created a right angle, so therefore we have here our uh, we can use the Pythagorean theorem. And for this problem, since this is an equilateral triangle, therefore it's also equiangular. Therefore, all of the angle measurements are 60 degrees. So if this is 60 degrees and this angle here has been bisected, okay, so that's 60 all over 2. This angle here, it's gonna be 30. This angle here is gonna be 30. This one is 60, and this is 90. So therefore, we have a special case. We have the special right triangle, the 30, 60, 90 triangle. And according to this theorem, so if this is 4, then the measurement, according to this formula, if this is 4, then the side measurement of this side is gonna be 2, and the side measurement of this side is gonna be 2 square root of 3. So how did we get that the height is equal to 2 square root of 3? Where did that come from? So let's go here. If the measurement of, if we're going to use the Pythagorean theorem, so that's a squared plus b squared is equal to c squared. Therefore, we can say that since 4 is the hypotenuse of this problem, we can say that a squared plus b squared is going to be equal to 4 squared. And then we have 2. We have 2 here as one of the measurements. So why is this 2? Because this is 4. The side measurement of LV is 4. And since it's been bisected, so 4 divided by 2 is just 2. So that's going to give us 2 squared plus b squared. So therefore, b squared is going to be equal to 16 minus 4. And b squared is just going to be equal to 12. And what's the square root of 12, guys? So b is equal to 2 square root of 3. And the height is, of course, equal to 2 square root of 3. And that's how we got the height for this triangle LUV, the triangular solar panel. So therefore, this will give us 1/2 times 4 times 2 square root of 3. Okay, so therefore, this is going to give us 2 times 2 square root of 3. And what's 2 times square root of 3, guys? 2 times 2 square root of 3. So that's going to give us 4 square root of 3 squared meters. centimeters. So therefore, the area of this triangle, using the special formula for finding the area of an equilateral triangle, and also using the basic formula for finding the area of a triangle, they both give 4 square root of 3, and that's how we solve this.